Well, hello. Today we are going to be talking about order of operations with fractions. Now, this is going to kind of be a summary of everything we've done in this whole chapter so far. So we're going to be finding least common denominators. We're going to be working with positive and negative numbers, adding, subtracting fractions, multiplying, dividing fractions, all kinds of things. So if you've been struggling with the other concepts from this chapter, you want to go back and review some of those things, because I'm not going to spend time explaining too many of those very basic ideas here. We're just going to be working through some sample problems and just showing you how to do some of this stuff. Okay. So you'll recall from previous lessons that whenever you're multiplying a positive and a positive, you get a positive. A negative and a negative makes a positive, right? Two negatives when multiplying make a positive. Like the opposite of the opposite takes it back to a positive in this case, right? And of course, when you're multiplying, a positive and a negative will make negative, and vice versa. That'll still make a negative. Division are all the same rules as multiplication, and that's just because division is the same as multiplying by a reciprocal. So they do have all of the same rules. Okay? If there's one negative in there, a positive and a negative, then it's a negative. If there's two negatives, then that makes a positive. Okay? One last thing to consider is that whether the negative is on top or if the negative is on bottom, most of the time you'll see me write it like this. That's just pretty traditional to write the negative out front. I do also do this one quite a bit. We pretty much never leave a negative in the denominator. Okay, let's get started on a few problems. So hopefully you remember that when you're multiplying, you don't need to get common denominators. We just go through and multiply them out. And so I could just multiply straight across and get 24/60ths, and then there's a negative sign here. And that would work just fine. The problem is that this is not reduced yet. There's nothing wrong with that. If you look at this, you can say, oh, well, I see 6 goes into this. Actually, an even bigger number. But maybe you don't see it. So you say 6 goes into this. So that would get you -4/10. And then you say, oh, 2 goes into that. -2/5. That is our final answer. Now, me personally, when I do this problem, I think of it as saying I can do some reducing. 4 and 8 reduce down to 2 and 1. And 3 and 5, those are going to reduce down. That's just a 5 and a 1. Now when I multiply across the top, I get 2, and when I multiply across the bottom, I get 5. And you can see I still have one negative sign here, so that's just -2/5. Okay. For the next one, I'm going to go through. I see that these are all being multiplied. Remember, whenever we have parentheses like this and there's no sign in between, when they're just pushed right up next to each other, that means multiplication. Multiplication. Now, these terms are they're said to be juxtaposed. It's called a juxtaposition notation. Just means that if two numbers are pushed up right next to each other with nothing in between them, we multiply. That's just pretty standard. Okay. So I'm looking for things that can reduce. I see that 4 will reduce with 8. So 4 goes into 8 2 times and into 4 1 time. I also see that 3 and 9 will reduce down. This is a 3 and a 1. And ooh, I see one more. You see this 2 right here that we made? And this 2 down here? Bam, those are going to cancel out as well. So that leaves me then with just a negative. And when I go across the top, I get 1/3. Oh, negative and negative make a positive 1/3. All right. All right, for the next problem down here, you can see we have a mixed number and just a regular fraction. And when I look at this is something I didn't do here. I should have counted the negatives. See up here, there's 2 negatives. And so that's going to imply that our answer is positive. And so down here, when I first look at this, I see I only have 1 negative. And since I have 1 positive and 1 negative, then that means that my answer is going to be negative. So I know that right away, that my answer should be negative something. The next thing that I'm going to do is change these. I'm going to convert these from a mixed number into an improper fraction. So I'm going to do 5 times 1 is 5 plus 4. So that's 9/5. For the other part of this, I don't need to change anything at all. It's just going to be times negative 5/6. And so when I look to see about doing some reducing here, I can say the 5 and the 5 will cancel. That's just 1 and 1. And then as far as the 6 and the 9, I go 3 goes into 9 3 times, and 3 goes into 6 2 times. So now I'm left to just multiply. 3 times 1 is 3. 1 times 2 is 2. That gets me negative 3/2. I know it's negative because from the very beginning I said a positive times a negative is a negative. Okay, this next one's a good one to pause and just do it. Actually, any of these are good ones to pause and then just work ahead. And then if you get it wrong, you're not quite sure, then come back and watch me do it. But you can do a lot of these, I'm sure. The first thing to notice on this is that we have one negative, so my answer will be negative. The next thing that I see is I can do some reducing with the fifths. So I can say 5 and 5 reduce down. And I can say 2 will reduce into these. 2 goes into 6 3 times, and 2 goes into 2 1 time. So now I have 1 times 1 is 1. And on bottom I have 3 times 1 is 3. And then I still have my negative out front from whenever I first started. That's how I know my answer is negative. Okay, out here on letter E, I've got negative times negative, 2 negatives. That tells me right away that my answer will be positive. So I know that my answer is going to be positive without doing any more work, just because there's 2 negatives here. Now, what I can do, though, is I can do some reducing, and I can say that I know 4 and 2 will reduce. 2 goes into 2, 2 goes into 2 1 time. Let's put a 1 here, and 2 goes into 4 2 times. Also, 3 goes into 9 3 times. 3 goes into 1 1 time. There we go. So 1 times 1 is 1. On the bottom, I get 2 times 3 is 6. And then I have negative times negative is a positive. So my answer is positive 1/6. Over here, I can see 1 negative sign, so my answer will be negative. Whenever I'm looking for things to reduce, 2 doesn't go into any of those. And of course, if 2 doesn't go into them, then 4 definitely won't. So I just multiply straight across. 3 times 1 and 4 times 2. That's going to get me 3/8 will be my answer. And I know it's negative because I had 1 negative sign, right? So I had 1 negative sign. That's how my answer is negative. All right, as we start to wrap up the multiplication side of things, we've got this. In order to multiply these, remember you have to have these as improper fractions. That's the only way that you can multiply these types of fractions. Change them to improper. I see 2 negatives, and of course we know that when we're multiplying 2 negatives, the answer will become positive. So I know that right away, that my answer will be positive something. We don't usually write a plus. I just put it there just because. So whenever I change this negative 1 and 2/3, that's 3 times 1 is 3, plus 2 is 5. So 5/3 times 3/5, and of course they're both negative. Negative times negative is positive. We actually don't even really need those. The nice part about this, look at this. 3 goes into 3 1 time. Bam, those cancel out. 5 goes into 5 1 time. Those cancel out. The negatives cancel out. Final answer, just 1. That's it, just 1. The last one here, we'll go ahead. I see 1 negative sign, so my answer will be a negative. I usually like to put that first. That way I don't mess it up like I did at the very beginning. Then I see 5 goes into 15 3 times. So 1 times 7 is 7, and 16 times 3 is 48. That gets me 7. Let me write that a little more clear. so you don't think it's 98ths. And the answer is negative. There we go. All right, so that's our multiplication of with positives and negatives. Okay. Next, let's go through and look at a few division problems. Now, the nice part about division is that it's the same as multiplication, it's just its inverse. Multiplication and division are inverse operations. So to divide by a fraction is the same as multiplying by the reciprocal, or the refliprical, as I like to call it. We're going to flip this over and multiply. Some people also learn this with keep, change, flip. So maybe you were taught that at some point. You keep the original fraction, you change the sign from divide to multiply, and then the second fraction you're going to flip. This becomes 15/14 negative. Notice the negative doesn't matter if it's on top or bottom. It doesn't. I do see, though, that I have two negative signs, and negative are going to make a positive. So my answer is going to be a positive number. So I got to keep that in mind. It's going to be positive. Now let's come back and look and see what we can reduce. 7 and 14, those will reduce. 7 goes into 14 two times, and 1. 10 and 5. I know that 5s fit into there. 5 fits into 10 two times, and 5 fits into 15 three times. If you're not sure about that, you really need to learn your times tables. Times tables are like, it's like knowing the letters. You can't read a book without knowing your letters. Knowing your times tables, you got to know them. Okay, so you got to know that 5 fits into those pretty comfortably. All right, now I just have 1 times 3 is 3, and 2 times 2 is 4. 3/4, positive. Done. Okay, let's really get to it because we still have 7 more of these to do. Look at all those we're going to finish up here in the next few minutes. All right, here I've got some mixed numbers. And remember, in order to multiply or divide mixed numbers, what do we need? Common denominators? No, not common denominators. We need to have them as improper fractions. So I will multiply and then add. So 15 times 3 is 45, plus 4 makes 49/15. For the second one, I take 10 times 2 is 20, plus 1 makes 21/10. Now, remember, now that we have these as improper fractions, now we have to take care of this division sign. So we'll keep the first fraction, 49/15, times, and then we flip the second fraction. That becomes 10, not 10, 15. We've got 10 21st. Okay. So we're going to rewrite this so it looks a little nicer as well. There we go. Now we're going to look and see what cancels. Look at all this red and green. It's like Christmas. So 7 fits into both of these. 7 goes into 49 7 times. 7 goes into 21 3 times. Then for the 10 and the 15, I got to think about what numbers go into there. Well, 5 fits into both of these. We just did that on the last problem. There we go. Now I have no more factors on bottom that are common to the top. That gets me 14/9. And now I got to check and see, is this going to be positive or negative? Well, this one's positive, that one's negative. There's only one negative sign. That means that my answer will be negative 14/9. More mixed numbers. Quit jumping around. Why my computer likes to do that. We've got more mixed numbers. We've got to have a negative answer because I have exactly one negative in the problem. So this is 32 plus 3 makes 35/8 divided by 2 times 3 is 6, and then plus 1. 2 times 3 is 6, plus 1 is 7 halves. Remember, we're going to keep the first fraction. We're going to change this to multiplication. We're going to multiply by the reciprocal. So 7 halves becomes 2 7ths. To divide by a fraction is the same as multiplying by the reciprocal. Then we'll come back through and say 7. And hey, I see you, 7. 7 goes in here 5 times. 7 goes into 7 one time. And then here for the other one, 2 is going to fit into both of those. So 5 times 1 is 5. 4 times 1 is 4. And we still have that negative out front. So negative, I'm going to write it in green. There we go. So now I've got negative 5/4. Now what's interesting about this next one is notice we don't have a fraction. We have 6 divided by this. But whenever we're working with fractions, it's always nice to write everything as a fraction. You can change any number as a fraction. Just put 1 underneath it. Boom, now I got a fraction. So I have 6/1 times the reciprocal, 5/3 negative. There we go. I can do a little bit of canceling. Say 3 goes into 6 2 times. And then that just gets me negative 10/1, which we don't usually write it like this. That looks kind of weird. So instead, we just say negative 10. There you go. Here we are down on letter E. Look, we're halfway done with the division. I see the division. I see 2 negatives, so my answer will end up being positive. So I've got 5/7 times the reciprocal, 6/5. Right? The reciprocal means to flip a fraction. Right? And we've got 5 and 5. Those cancel out. That's kind of nice. And so I've got my negative right here. There we go. Negative, negative, make a positive. We already talked about that, though. And so then I get 6 on top and 7 on bottom, and that's it. We're done. 3/8 times the reciprocal, the refliprocal. So this is this is 1 negative. That's 1 positive. That means my answer will be a negative amount. I do have something that fits in here. So 8 and 12, those will reduce. If you didn't see that, it's no big deal. You would just get 36/40 and then have to reduce from there. You'd probably say, oh, look, I see they're both even. So that would be 18/20. Oh, they're still both even. That's 9/10. So my answer is negative 9/10. Now, if you were going to reduce on the front end, which is what I would probably do, I would say 4 goes into each of those. 3 and 2. That still gets me 9/10 negative. All right, last couple here for this section. I'm going to do 5 times 5 plus 3. That's 28. I guess we're working in blue now. And then we've got divided. That becomes times. The reciprocal. Flip it on over. 10/7 negative. Before we go on, is the answer going to be positive or negative? Yes, there's 1 negative sign, so the answer is negative. The next thing that we're going to look at then is to see what we can reduce. Your eyes are probably going right here. Most people like 5s and 10s, right? That's going to be a 2 and a 1. But I like 7s and 28s. Did you know 28 is considered a perfect number? You should Google it. Or Microsoft, whatever, Bing it, I guess. You know, or if you're an Apple guy, you can Safari it. Oh, Siri knows. Ask Siri what a perfect number is. Anyways, so we've got 7 and 28. Those will reduce. So this becomes a 4 and a 1. Notice we still have this negative sign here, so it's 4 times 2 is 8. That gets me 8/1. But remember, we don't usually write things like that. We just leave it as 8. Last problem. Not much to do here. I see there's 2 negative signs. So I see it's a division, so I got to flip it. That's 2/15. Negative. Negative and a negative are going to make positive, so keep that in mind. And now we do some reducing. So we'll get 5 and 15. This is down to 3 and 1. And 2 and 8, those will do some reducing as well. That's a 4 and a 1. What I did was I divided a 2 out of each of those. Again, if you're uncomfortable with that, you probably ought to go back to some previous lessons and look that up. All right, so 1 times 1 is 1. On bottom, I get 4 times 3 is 12. And of course, negative times negative is a positive, just like we said at the very beginning. So that gets me 1/12 positive for our final answer. All right, so I think that's probably enough of these for now. Hopefully you're able to get them. Again, hopefully you only needed a couple of these. Maybe you didn't need any of them. You just were working on your problems, you paused me, and maybe you even muted me so you didn't have to listen, in which case you're probably not listening now and you're wondering, why is this screen taking so long? All right, well, good luck with all your other fractions.